Morning everyone. Today I will be teaching you about the question tutorial section A, question number 1, which is this one. They want you to convert milligram to kilogram. Okay, first thing we need to do is to list out the series of unit conversion. We know that kilo is equal to 10 to the power of 3 times 10 to the power of 3, and milli is times 10 to the power of negative 3. Alright, now we take this number and equal to kilogram, which will be 891,000 mg equals to something that is kilogram. Right. So in order for you to change this, we need to times milli, times this number with milli, this one. So 891,000 times 0 to the power of negative 3. This means you are converting milligram to gram back to its normal position. Therefore, you will get around 891 gram. Now, for you to change to kilogram, you need to divide everything with 10 to the power of 3. You will get 0.891 kilogram. Alright, so here is basically basically the same. But in the question, however, it doesn't show like this kind of bentuk soalan seperti ini. But it shows something like this. In order for you to get the question that is same in the objective question, you need to move the point to behind a little one more decimal point. So it will be 8.91 times 10 to the power of negative 1 kilogram. This is the answer for question 1 in tutorial 1. Alright, starting. This is the question number 2 in topic 1 in the section A. What is dimension? Well, first of all, we need to look at each of the question, the example we're given, which is the D, a technique to construct an equation. We all know that dimension is when you use something and you break it down into more basic thing. So a technique to construct an equation is definitely not this one, not the meaning of dimension, since an equation you can create using a physical equation. You can create an equation using basic equation and also physical equation. C, so shall I, the D is wrong. So C, a technique or method to determine the homogeneity of equation. It could be right, because sometimes in order to find the homogeneity, basically we are using dimension. Homogeneity means where you have one equation here, let's say for example equation E and equation AB. Homogeneity means where the exact basic quantity are basically the same in left hand side and right hand side, where the basic quantity of this and this are the same. If the basic quantity of E and B is not the same, then it is not homogeneity. The answer for C can be right, can be correct, but let's just leave it for now. B, a technique or method which basic quantity can be expressed in terms of combination of physical quantity. Before you say this right, look carefully. All you see is basic quantity can be expressed, which means you are breaking down the basic quantity into physical quantity. We already know it's wrong because a basic quantity means you no longer can break it down. Basic quantity means the most simplest, like for example temperature. You can no longer find, this is not temperature, this is time. Temperature or time, whatever. So this is basic quantity. You no longer can break it down because this is the most simplest. Whatever you do using everything physical, you cannot find it because you can only obtain this kind of quantity by measuring. So we all know the B is wrong. Now A, a technique or method which physical quantity can be expressed in terms of combination of basic quantity. I think you guys already know this is the correct answer, since we all know physical quantity can be expressed in terms of combination of basic quantity, where you are breaking down physical quantity into its component, which is the basic quantity. Now, but however, we know this, even we know this is the correct one, how do we know this if the C might be the question? Okay, like I said before, homogeneity means trying to find the basic quantity of each left hand side and left hand side are equal. However, that's how you find, not what is the meaning of dimension. Dimension basically means you are breaking down apart, not trying to find whether it is the same or not. So because of that, we already know the answer is A. And now, this is the question 3 for topic 1 in the section A. Find the dimension for K. We want the smallest basic quantity for K. Alright, we all know the formula for the momentum is basically mass times velocity equals to K times the density. The formula for density is mass times over volume. Basically means mass over volume. Alright. Now, before we want to find K, the dimension for K, do not forget one thing. This is the most students forget because they thought it was easy. Before you, I know you guys will like pindah everything to here, but do not forget this one simple thing that might get you a mark. K in a square bracket. This is dimension. Most students forget this, but don't worry, I also forget it. Alright, now we transfer this one into the other side. We will get M, V, and M. So M, V, and over M. Alright. Now remember, the V here is different. V capital and V small. V capital means volume and V means velocity. Do not forget that. That is very important. Now we can cancel out M because it's basically the same. So we got V. Now we know that V. Since you guys don't know, so I'm going to explain in detail here. V we know means L over time. So if you do, you will, if you do, you will get L times T negative 1. This is the dimension for V. Now we transfer this to that one, we will get L T negative 1 or negative 1. Alright. Now V, remember, V is different. It's not a velocity, it's a volume because it's a capital V. So V, we know V is cm cube, right? Cm cube means like L cube bar. So the dimension for V capital is L cube. This is V. Now times L equals 3. Now I think this is very simple for you guys. You just multiply everything. You will get K as L for the top and times T negative 1. And this is the dimension for